Welcome back, or hi again. I'd like to give you all a demonstration on torch cutting, and I think I have a really good torch cutting technique that I'd like to share with you. We're gonna cut out this gift, and it's for the entryway underneath or above a gate. And so what we've done is we've made a stencil. And what I've done in the past is I've cut a stencil out and you can spray paint it, and then when you remove the stencil, then you have the silhouette. But in this case, I'm just using this stencil on a hinge so I can go back and forth, and I'm using soapstone. It's a little better breathing. I don't want to breathe the burnt paint. The burnt paint does kind of, it stays on quite a bit better than the soapstone. So I want to talk about how to lay out something on a piece of steel. So this is a piece of plate. I bought this plate probably 30 years ago. I laid out a gate on it, and since then I've been using this as a tabletop, and then it found its way outside. That's why it's pretty rusty. So the rust is going to prohibit you from having a clean cut. So the first thing I did is I got my cut brush, and I cut brushed the to get the scale off. It doesn't matter on the bottom, but on top it does, because it's going to interfere with your cut. So that's cleaned up, and I want to talk about how to adjust your torch, how to select the right tip. I want to talk about how to clean your tip, make sure that you've got a stinger that spits. It's very important, and once you see that, you'll know that that's going to give you a real clean cut. I want to talk about how to start from an edge. I want to talk about how to start in the middle, which is basically a plunge cut. So I want to demonstrate actively on this, and we will probably do a fast motion photography of me cutting the bear out. So this is a bear riding a surfboard, if you can't tell, and we're having issues right now with that too, making slight adjustments. So we may be making adjustments along the way. But this is the state motto of California, not on the board, but the bear itself, and then it's got a star on the flag. And so the star may or may not be included in the composition, but I'm going to go ahead and give it to them as a congregate gift, just in case they want to somehow hang it, and it will have a welded bar on it. I'm not really sure how it's going to hang. So, but I want to use the star as an example of how you transfer a design onto a substrate, the surface. So the first thing I do is I would flip the drawing over and try to locate where the star is itself, or whatever it is that you're transferring. And I'm going to use a Sharpie because, and just to get a kind of an idea of where it is. Okay, so that's where I need to put the transfer material. Oh, I got a cap here somewhere. Oh, there it is. So what I do next is I'll put some soapstone on this. Now, what I understand from soapstone, I never thought about it before, but this stuff is not innocuous. You may want to not breathe this dust. When I bought this the last time, it had a warning in it that it can contain asbestos. So just be really careful about soapstone. It's not as seemingly innocuous, but what I'm doing here is making a carbon paper out of just your drawing and soapstone. And so it doesn't have to be exact, because when I go backward on the other side, that's when it's going to be exact. So I'll be real careful about this, and I'll toss it outside or breathe it in smaller increments. So now I've got that hinge. I'm going to flip this over, and I'm going to get a harder edge item, which in this case it's a pencil, and I'm going to go over it. I'm going to just make sure that this is transferring, and it's not. I can see my smear of, let's see if that does it. Nothing like something not working perfectly the first time to learn. Okay, so can I see that? I need a little bit more than that. So really what I need is this transfer, and then I'll go back and confirm it with the soapstone. And there is my transfer. Now I'm going to confirm it with the soapstone. Like that. All right. So now I need to cut it, and you could cut it using a jigsaw mechanically. You could cut it using a grinder with a thin cutting wheel, or if you use the torch, and the torch is something you should have in your blacksmith shop or your fab shop or your artist studio, then that is a multi-purpose tool. So what we'll do is we'll use it using the torch. And so this is I think they call this the Journeyman, and it's the smaller Victor torch. You can also, if you have the contractor, and this is an old contractor, it's a nice thing about these old or long handled big torches is that it gives you a lot of leverage. And so when you scribe an arc, for instance, it's not as shaky. But most people in the smaller shops are going to have the smaller torches, Gentech, or in this case, this is a Victor. And it's important too to have a good variety of tips. So I've got a number of variety of like heating tips, and I've got a variety of cutting tips. Now everybody knows that this torch head, the handle itself, it accommodates a number of different fixtures. This one is dedicated. It's dedicated to cutting, but this one has, you can put a heating tip on it. You can put a rosebud on it. A rosebud is your multi-fuel apparatus MFA tip right there, and so it's got all of these orifices that are measured so that it puts out a certain amount of BTU, and BTU is given to you in the torch size. So this is an MFA 1, and they go up to like 10 or so. So that's for heating. And in the case that we're going to be putting the cutting head on it, and I always put the head of the tool down so that I don't cross thread or drop it on the ground. So put it on the table, and then that way you can take your time threading it. What makes the seal on these is the O-ring on that. So just be careful not to go gorilla tight on this. You just go monkey tight. And it's just tight enough so that it doesn't swivel. And so right now it's swiveling, it's not tight enough. Always put your adjustment valves on top. If I'm left-handed, then this is what the setup is going to be. Right-handed, this is the setup. Okay, so that way they're out of the way. You can make minor adjustments here. They don't mess with your orientation of your hand. So always do that. Now I'm going to tighten up that so that it doesn't spin, no longer spins, but I can feel it compress against the O-ring, and that's the idea behind the tightening of that. So that's not that faceted. It should be knurled really instead of faceted like a nut. So you don't want to use a wrench on that. Now on the other hand, you do want to use a wrench on this. If you don't use a wrench on this, you're going to get some vacuum, and it's going to pull air into there, and it's going to really make your torch cut poorly. And you also may get a flame coming out of here, may get a flame coming out of there. So right now this is, no, I guess it is snug. Now if you're doing a lot of cutting forward and backwards, you may want to align on a torch tip. You've got on the smaller ones, you've got these 6 preheat orifices, and then you've got that high pressure oxygen orifice in the center. High pressure orifice oxygen is what does the cutting. The preheat orifices bring the steel to kindling temperature, just like the kindling on a fire. And if you do a lot of cutting straight up and down, then orient the preheat orifices so that that orientation is, as you can see, there's a top hole and a bottom hole. If you're doing a lot of side to side, orient your preheat orifices so that they run side to side like that. So it's just a little tip. If you're doing organic shape like I am, then it doesn't matter. So this needs to be snug. Now I haven't cleaned this tip, so I'm not really sure what condition it's in. I hope actually it's dirty. I have a new tip. I have various new tips. This is a double aught. A double aught is when you look at the numbers on this, for cutting torches, the first 2 numbers are the size of the tip. The next 4 numbers are the series of the torch. So when I'm looking for, this is an acetylene tip and it's double aught, and double aught will cut 1/4 inch. Okay, you can push a single aught to cut 1/4 inch. You can also push a single aught to cut 1/2 inch, but it's best to get the specific tip that is recommended for that thickness. And so this is a double aught, and I'll probably change this tip out, or if this tip on here is it's a single aught. But I want to demonstrate what, if that tip is dirty, what the cut looks like, and then after cleaning it, what it looks like. So now on a single aught, you'll see that it'll cut up to 3/8, and your recommended cutting oxygen pounds per square inch is 25 to 30. The preheat fuel, which is 3 to 5. That's important to set these at that pressure. Many of the people that I've run into are pretty arbitrary as far as setting the pressures on their regulators, and I find that you'll get a lot better results if you set these pressures properly, and I'll show you why. So your inches per minute are 20 to 24 inches per minute. So it's a little slow. Well, actually, it's faster than this. It's slower than that, but you can exceed it. But really, your cut is going to dictate how fast you can go with your whether your cut stops or whether you're fusing your material back together. And this is how much material you're going to expect to remove with a clean tip, about 60 thousandths of an inch. So that's like the thickness of 1/16 of an inch or so is what your kerf is going to be. So these are always very important. You can get this online. If you buy a Victor torch, that always comes with it. That comes with a booklet. I don't know, welding supplies will give you these things out too. So it's important to have that card, because you can memorize them, but if you do a lot of different cutting, then you're going to have a lot of different specs. So this is tight. This is pretty much gorilla tight. That's monkey tight. These are also monkey tight. Don't tighten these things too much, because you just want them snug, because you'll wear those needle valves out. Now, I don't have a flashback arrestor on this torch. Frequently have flashback arrestor at the source. So on acetylene, you have to think about flashback arrestors, because acetylene could burn back into the torch, and it burns anaerobically, so it doesn't need oxygen. And typically you'd have a flashback arrestor on both of them. They're not only flashback arrestors, they're check valves. I have a flashback arrestor on the torch, on the bottles. Bottles are over here. Right now, I'm in the midst of rearranging my shop. I put a floor in, and that was some work. And I'll explain what the floor is all about, and holes in the floor and my touch mark later. But for now, things are kind of temporarily where they are as tentative. But my torch is back here behind my fly press, and I've got my flashback arrestors on my torch. So you may ask, why put a flashback arrestor on oxygen? And that's the question I asked too. Didn't make any sense, because oxygen is not burning, the acetylene is burning. It's because if the gases mix inside the line. So they're not only a flashback arrestor, they're also a check valve. So check valves only allow the fuel to flow, or the gas to flow in one direction. So in this case, it freely flows this way, it does not flow this way. So it won't like bleed any combination of gases pass this. So if I had oxygen acetylene in that regulator, it would explode. So it's really important to have flashback arresters on your, either on your torch or on your regulators. Okay, so this is your oxygen bottle, is your acetylene bottle, and you might be using MAP, you could be using propane, and those are slightly different adjustment, but not too far off from what I'm going to show you. So when I turn my oxygen on, I always put the regulator away from me, because if this, in any situation that comes up that maybe there was some grease on these threads and this regulator comes apart, then you want it on the other side of the valve from you. And always turn your oxygen on slowly until you reach full pressure. In this case, my full pressure is PSI, it's like 600 PSI. And and I go all the way with it. Now, what this does is that seals up this valve against the inside of that tank. So now that's always full blast. Now now notice that there's no pressure on this, because every time I use my torch, I shut it down. I don't want any pressure on the regulators, because if you have pressure on the regulators, eventually these regulators will creep, because there's a diaphragm in there and there's constant pressure against the stainless diaphragm. It'll bend, and then you'll never be able to turn it off. And then you'll note if your regulator creeps, if you set your pressure and then your needle just keeps raising up. It's a little creepy, literally, and because your regulator is creeping, and you really need to have your regulator rebuilt if your regulator is creeping. And it's a good idea to buy more name brand equipment than trying to save money, because there are welding distributors that sell this equipment will rebuild these for you as well. If you've got an off brand, then chances are that you're not going to be able to rebuild it. So now I've got full pressure, and this reads how much pressure is in the tank, but that's way too much pressure. I got 600 PSI. I said there I needed 25 PSI, 25 to 30 PSI for cutting. So what I need to do is I need to regulate that with the regulator, and I'll do that by rotating this to 25. Now sometimes it's hard, because these increments, they probably should be in smaller increments so that you can really dial that in. So right between 20 and 40 is 30, and then halfway, so it's the next one up, that's my 25. Now I'm going to go ahead and set my acetylene regulator as well, so that's 3 to 5. And I want to talk about the difference between line pressure and running pressure. So on the acetylene, it's not high pressure, because your acetylene gas is dissolved in acetone with Fuller's earth as the buffer, and whatever evaporates off of the acetone is what you're going to be able to use as useful pressure. And acetylene, you typically don't want to go higher than 15 psi, because you can push it if you're a pro and you've got some experience, you get a 17 psi, whatever. But if you push past 15 psi, what's going to happen is you're going to pull some acetylene into your torch, and it's going to really disturb your cutting. And also, if you run too high pressure with acetylene, then acetylene, since it burns anaerobically, it can also potentially create a explosion hazard. For instance, if a forklift ran over a hose with high pressure acetylene running through it, then it would cause an explosion. So just be real careful about that. Now, how much pressure do I have on my acetylene? I have, that's almost a full tank on this. So I've got about 240 psi, which again, I only need 3 to 5, and that's the job of your regulator, is to regulate that. You can see there's no pressure on that, because I always shut my regulators down. They last for years if you shut them. These regulators are so old. This one in particular is an old Harris. So I need 3 to 5, and I'm going to go to about 4. We'll see what happens. Now, if that needle continues to climb, then it's creeping, and you don't want to use it, because for those reasons, that you're going to be pulling too much acetylene to the point in time you're going to be pulling acetone. If this is creeping, so that's at 25 or so, then you want to shut this down, because this could also be dangerous, and you'll see that the effect that it has on your cut, on the quality of your cut. Okay, so this is set. Now what I want to do is I want to show you the difference between running pressure and line pressure. Right now we've got line pressure, and I can tell you that I'm running 25 psi, but if I open up my valve, so this is your oxygen valve, but this valve now supersedes that valve when you have a cutting head on it. So when I open that up, nothing happens until I open this up. Now watch when I open this up, and watch that needle. It dips a little bit, and I close it and it goes back up. Dips, goes back up. So I'm going to suggest that when you set your pressures, and I want 25 psi on the oxygen, I want it to be running pressure. So that's my running pressure, not line pressure. So there's my running pressure. Now line pressure is going to be higher. So line pressure is probably 27. And the same thing on the acetylene. Now I don't know if that's creeping, and I have to keep my eye on that. I do have another regulator in case that's creeping. I haven't used my oxygen acetylene setup in a while. So, but I want 5 psi on my acetylene. So let's see what happens if it drops. So you can see how much it drops. So if I want 5 psi running pressure, then I'm going to have to adjust this a little higher. So I'm going to go 6 on my line pressure, and when I drop it, I want 5 on the running pressure. Okay, so it should bump up a little bit and then drop when I open it up. Okay, so that's the difference between line pressure and running pressure. Now, camerawoman has furnace flip downs. So these are 3s. Typically you want 5s, anywhere between 3 and 5 for cutting, depending on the intensity of the cut. Thinner stock, you can use 3s for heating and light cutting. Heavier stock, you definitely need 5s. I find that I can see better with 3s. They are polycarbonate, and then I've got polycarbonate lenses in my safety glasses, so I'm getting most of the infrared and ultraviolet protection, and then the tint gives me comfort. So I need 3s because otherwise, so I know there's going to be some people that tell me 5s are the way to go, but I find I'll be walking around, walking into stuff. And what these are Phillips. These are Phillips flip down. At the time, they were about $12 each, and so you can spend a lot of money on these. But typically, what's going to happen with these is they're going to get laid down, slid across the table. So I find that the quality of these are really good. There's hardly any distortion optically, and so I like the way they feel. So let's check back and see, make sure I'm not creeping, and I think that's acceptable. I'm at like 6 psi, and I'm at 25 psi. So I'm good. I just want to make sure that it drops down to 5, which it did. Okay, so that's my line and running pressure. Now, let's talk a little bit about the oxy-fuel cutting, which is designated OXF, and then you could be M or you could be P or OX, oxy-fuel dash whatever fuel you're using. In this case, it's acetylene. We're going to create about 6,000 degrees. Steel melts at 2,800 degrees pure iron, 2,600 degrees carbon steel. So we have more than double the amount of heat that we need. So what does the cutting is the higher pressure oxygen. So it's at 25 psi. And when your torch tip has these preheat orifices, and so they come out at 5 psi, so it's equal pressures, 5 psi on these. When you depress your cutting lever, which I'll show you here in a minute, you'll get 25 psi out of the center. So what these will do is they'll preheat your metal to kindling temperature. Kindling temperature is when it just starts to glow, and then when you hit it with the high pressure oxygen, the oxygen burns the iron out of the steel, and it pushes the rest of it out with the high pressure oxygen. And so it's a pretty efficient process, especially if your torch is clean. Now, the torch tip on the outside looks like that, but if you do a cutaway, it looks like this. And so the hole for the center orifice is large, and it's swaged down to a small hole. So if you project that, you'll see that it creates a point. It's a nice needle point. Now, when they wear, or if they're dirty, what happens is yes, it's swaged, but then it flares a little bit there at the end, and maybe there's some gradu in there that's causing, and that'll really distort your but not only the preheating, but especially the high pressure oxygen. So it's really important to restore that. When you restore it, you need to restore it so that you get back to here where it's got sharp edges and there's nothing in here that's going to interfere with the flow of that high pressure oxygen. So when you have this, that's your stinger. Okay, so, and I didn't have any chalk, couldn't find any, so we'll deal with soapstone, but this is your stinger. And you have like a flame envelope that's created by the preheat orifices, and then your stinger goes straight through your preheat envelope, and at the end it'll crackle. If this is clean, then you'll get a stinger that crackles at the end, and that's what we call a stinger that spits. And I really like that term because it's something that will stick with you. I'm trying to think of the term in linguistics, but it's something that it's just like a earworm, where it's like now you're stuck with that, and then every time you use a torch from here on out, you're going to wonder, is that stinger spitting? Okay, I picked this up from a student back in probably '95, and he worked at the Texas nuclear plant, the South Texas nuclear project, and he was a fitter, and he told me how he cut, and he was very courteous about it, very polite. But I learned so much from that one episode, and this is what I want to share with y'all. I was initially really inspired by a fellow called Mel Borg, and I just did some research on him, and I found that he passed away. Rest in peace, Mel Borg. But he was an amazing torch craftsman. His torch cutting skills were impeccable, and I never really understood how he did it, but he made sure that he had the right tip size and the right pressure. And I never saw him clean a tip, but I know that he was very careful with his tips. I remember he had them wrapped up individually, and so back in the day when I worked in a fab shop, we were pretty much like we were hack and tack. I mean, there was no craftsmanship to it whatsoever. I decided to go in a different direction. This is like 1982. I decided that I wanted to pursue a higher degree of precision and craftsmanship and tradition, and that's how I got into blacksmithing. And he came into the shop, and he was able to work there part-time, and he created these beautiful signs, all hand cut from Oxy-Acetylene from 1/4-inch plate. And so the distinction here is plate is greater than 1/4-inch, and if you can use the Oxy-Acetylene process for thinner than 1/4-inch, then it's sheets. And it's a little tricky because you got to move faster, or you can tilt the torch tip. So instead of like the torch tip, for instance, coming straight down into the material, then you can tilt the torch tip, and if the material is really thin, then the angle through that is this long. So it's as if you're cutting this much material, but since you're cutting it at an angle, you're cutting it, which means you have to move faster. So you can use the oxy-fuel cutting process on thinner stock, but you have to tilt your torch. Now this is a 4-hand technique, so you're always pushing it because those preheat orifices heat the material before so that you can have that reaction between the oxygen and the kindled steel, iron. So you never use backhanded technique. You either go directly vertical or you do a slight 4-handed technique, okay, on Oxy-Acetylene, because that'll preheat your steel. Particularly on thinner stock, you really have to really tilt your torch and do a 4-handed technique, okay? So what I want to do is I want to strike the torch, and I want to see what the flame looks like and see if I get a stinger that spits. And I want to make a cut with it just the way it is, and then I'm gonna touch it up a little bit with a tip cleaner, and then we'll see if it makes any difference on the quality of the cut. Okay, so now I'm walking over here. Now I've got my pressure set, my Regulator's not creeping, both of them are set, and that's because I shut them down all the time. I'm gonna shut the torch down later on today. So what I'm gonna do is, so this is where it starts getting bright, and it's really not so much bright when you have both oxygen and acetylene. What's really bright is the acetylene. Acetylene was used for lamps, and miners had carbide lamps, and it was like basically burning acetylene because it's super white, bright white light. And so at this point in time, you'd want to, flip down your flip downs. So my valves are on top, and I balance the torch in my hand, and what I'm going to do is I'm going to crack the valve. There's one of two ways of striking a torch. You can crack the valve, or you can go full blast. I'm a little leery about that full blast method, so what I'm going to do is I'm going to crack the valve, and this should give me just a little bit. Now this is soot. You want to get past that soot stage. Okay, so right past that soot stage is the low range for this torch tip. So again, when you crack it, you're going to get a lot of soot. Go past that soot. You don't want to breathe that soot, by the way. That's pure carbon. So when I get past that soot stage, you can see it's burning clean now. That's the low range of your tip. This doesn't give you any heat yet, but this shows you how much volume you're going to be anticipating. So that's the low range. Now let me show you the high range. The high range is right before the flame jumps off the end of that tip. You don't want to have when you're adjusting your oxygen or acetylene, you always adjust your acetylene first. So you're going to back up until the flame reattaches itself there, and then you want to make sure that it's burning clean. So you don't want it to be sooty. You want to be right past that soot. Okay, so there's your low range. It's still attached. Now this is preempted. It's obsolete by this. I'm going to slowly turn this on, and you're going to see this is my feather, and you're going to see a cone develop in the center of that, the more oxygen that I give it. And so there's your stinger. You can see the stinger right down the center of it. You can see like the little feather there at the end. And now I'm going to keep going until I have a very refined set of preheat cones right there in leaving the tip. So little by little, there are that's the adjustment. Now you want to make sure that you're right on the money, because when I depress this lever, it's going to distort that. So what I want to do is I want to add enough oxygen so that those preheat flames are not distorted. Okay, I can see right now I've got a very short stinger, and that's nothing to brag about. I can work on that. So I've got a stinger that's that long, and it's not out here and it's not spitting. And I'm glad, because this is going to give us an initial cut. Now what I want to do, I'm going to make a cut, and make sure that you don't cut through your twin line. And I'm going to make a cut. I'm going to make a circle. And I'm going to make the same cut here and here, so that there's no, because if I made a cut here, then that metal would be preheated, and it's going to be easier to cut the second one. I want them to be the same. So how you create this cut, and by the way, you may want to be comfortable, and I'm going to wear a pair of, or just put on a single glove, and they're both right-handed gloves, of course. Put on my glove because I don't want to be distracted. I can cut barehanded, but I don't want to be distracted by the pain that's involved of burning my hand in order to get a perfect cut. So I'll move this out of the way. Make sure you're not cutting into anything. And this is the reason why I'm cutting inside, is because if I cut outside, make sure you got a fire watcher, because you're going to be creating a lot of sparks, and you're focusing on the cut. You're not focusing on the fact that your pants are on fire. So also I'm going to make sure that I don't cut into my twin line. Now they're heat resistant, but they're not. So I'm going to strike my torch again. Remember to get past the smoke stage. Then add your oxygen until you get your preheat orifices. Test your preheat orifices. Make sure that it's not fuzzy. And so that's going to be your initial cut. So what I'm going to do here is I'm going to start at the edge. Now notice the preheat orifices are just off of the material. So I'll show you kindling temperature. That's kindling temperature. See how it the steel can't conduct the heat away fast enough, and so that the steel starts to, it's not a bad idea. We can flip this up because I want to be able to use this as a reference for the bear. So again, I'm going to bring that edge to kindling temperature. I'm going to start my cut off of the edge. Don't start it here because you won't have a clean entrance on your cut. So kindling temperature, start your cut, come over here and move fast enough Okay, so that's not bad. To turn this off, do exactly the opposite. Turn your oxygen off, turn your acetylene off. Now, if you've got a little bit of flame, if you've got a little bit of flame at the end, then you can blast it off with oxygen, or hopefully it'll put itself out. If you're always gorilla tight on your needle valves, then you're going to wind up having a flame like that. Don't shut your torch down the other way, because that backfire, it pits your seat. So your seat is where the O-ring attaches to the handpiece. Victor recommends shutting the torch down in the exact opposite steps that you lit it. So I go by Victor's procedure. They're the manufacturer of the torch. Now, so my cut is not bad, and this is going to be hot. So there's my cut, and there's slag that's stuck on the edge of my cut, and you can see that I've got a little bit of slag here on the bottom of the cut. So now what I want to do is I'm going to clean the tip and take a look at the bottom of it too. It's got a little bit of slag there that may come off with a chisel, and you can sand it or grind it off. Now, I want to use the same tip in the same cut, and I'm going to see if by cleaning it, it makes any difference. So you have your tip cleaners, and I like the bigger ones, but I don't know if I'll ever use these. So yeah, the bigger ones make you look like big man on campus, but really you're only going to be using the small ones here. If they've got more of a variety in steps, then the bigger assortment is better. But this one works fine and they're cheap. And so you've got a file, and you can complain about that file, but really the file is good enough because you don't want to take much material off of the end of that tip. If you do, then you'll enlarge the orifice and you'll never get a clean cut out of that tip. Or since that tip is tapered because it was swaged, then you're gonna pull that tip back behind that swaging. So be careful about how much you take off, and on your torch tips, just make sure they don't fall and they get dinged, and don't use them to pop things out. So these are precision instruments. Now what I'm going to do is I'm just going to ream it, and I'm going to find the ream that fits into the preheat orifices, and maybe that one's for the, let's go with the oxygen first. And when I find the one, I'm going to isolate it. So it doesn't require a lot of sawing back and forth. So this is the tip cleaner for the oxygen, and I just want to go in and out until it feels smooth. Okay, that's pretty smooth right there. Now you can also clean, and I'm gonna, you can juggle through the smaller ones, but that'll have the tip reamers for the preheat orifices. But since I've got two here, I have the luxury of not having to fish about, and so I'll have, frequently I don't find that I have to ream the preheat orifices. Most of the time it's the oxygen that gets fouled. And so let's see. So I'm going to pull 3 apart and find out which ones. You don't want to enlarge the hole with the tip cleaners. It's a cleaner, not a drill. That's warm. Okay, so it's the smaller one. And as you get down to these small sized tips, so now I'm going to isolate that. And I'll go on every one of them. Now, to keep gradu, which is, I don't know, some kind of French term maybe, you can blow it out with your oxygen. Man, that one's tight. They will interfere with a clean cut if your preheat orifices aren't clean, but the main thing, and I'll keep this so close by, is this the high pressure oxygen. Okay, so now let's say that that's clean. If I needed to, and if it got dinged up, then I would use the file that's in these kits and file it until I got the copper color all the way around that hole. I'm not going to do that because this doesn't need that, but we'll see. But the file, don't use a heavy file, because you'll file right past the size of your rated tip size. Okay, so now what I'm looking for is a longer stinger, and hopefully I'll get it to spit. So I'm going to go past the sit, and that's my low range. What I mean by low range, I can run more. Now I just ran more. And that's if I find that if I'm at 5/16 or my technique requires that I move a little faster, then run it at high range of that tip. It doesn't make it hotter. The temperature is still 6,000 degrees, but it gives you more heats. It's like more water in a larger hose. It's just, so if you can kind of put your mind around that. So this is already on. Now what I'm going to do is I'm going to slowly give myself a... Okay, so now look at my stinger. It's that long. You can hear it spit. That's a clean tip. Okay. Now let's see if it made any difference as far as the same cut. So bring the edge of the material up to kindling temperature, and you can tell if you're kindling temperature when you pull off, it stays orange for a second. So kindling temperature off. So again, to shut this down, turn your oxygen off first and turn your acetylene off. If you have to, give it a little blip of the lever. Okay, so let's see if just that amount of care, and again, be careful how you lay your torch down. Don't lay it down on the tip. So now I can see that the hole is quite a bit cleaner. It doesn't have near as much slag on it, gradu on it. And then here's your drop. And you can see it has very little dross. It has very little slag that's clinging to it. So it's really worth it to go over the proper torch pressure, the proper size tip, and making sure that you have clean orifices so that you can see it with the stinger and you can hear it. It's going to crackle there on the end. And when you have those combinations, it's really going to be up to you how clean your cut is. Now, I made these cuts by cutting off of the side, and in fact, this plate that I put into the foundation, it's 1-inch plate, 5 feet in diameter. Actually, this one doesn't. I thought it did, but it does have a. This was cut with water jet, and it was mistakenly cut there in the center, and that's why that wound up in the junkyard. But frequently, you'll see on large discs, you'll see a line coming in from the side, and then you'll see that they make the cut. So this is how you typically enter a cut. Now you can plunge cut. So what I'm going to do is I'm going to make the same cut right here, and I'm going to plunge it. So this has been cooled off for a while. It's about 100 degrees. So I don't want it to be like, oh, he can make that cut because it's preheated. Or you can preheat your steel and make your cut go more easily, especially thicker stock. But it's also a double-edged sword, because if you preheat it too much, then when you're making your cut, the stock may fuse behind that cut and it won't be as clean. So when I cut this bare, for instance, and I'm cutting these claws out, what I'm gonna have to do is go really fast and then maybe take a break so that I cool it down a little bit, and then finish. When your cut is like real tight and you're making a lot of cuts, then you're gonna get that steel so hot that it's probably gonna fuse together. So now I have a plasma torch, but on steel, I prefer to cut with a torch. It's cheaper. If the torch is in the shop, my plasma's in the garage, keep it from getting dirty. But if I'm working non-ferrous, then I'll use the plasma, because the torch requires that you have something that is iron in it in order for that oxygen to come out with the iron and then create that very thin burn. So I really like my plasma, but I really use the Oxy-Acetylene the most. So Oxy-Acetylene, I don't have a rating that's, I have a 375 on my plasma torch, which means that it'll hack through 3/8. Best cutting is 1/4 inch, and even then it's got a duty cycle. But with a torch, I can cut all day, 2 inches plate. I built this power hammer, and this is 2-inch plate, this power hammer behind this chalkboard, and I hand cut all of this with a torch. Now, did I hand cut that? It's a pretty nice bevel. No, I didn't hand cut that, so I'm lying to you. What I used was this device. So it's a tractor-driven torch. So it's the same parameters that, let's see. Okay, so it's the same parameters as far as like setting up, making sure you have the right size tip, make sure you have the right size pressure, make sure you have a stinger. In this case, that's your lever. So you have your flash arresters here. It's right next to where you're creating the work, so you don't have any flashback that goes past here. And this acts as a check valve so that there's no mixture of gases in these lines. So anyway, so this is a neat tool, and this is something that we'll talk about in a later video. But when you're cutting 2-inch plate and you need a 30-degree bevel on it, this is the tool to do it with. Or you can do it by hand, but still have the advantage of a motor. And so this is a motorized torch, and these things are a lot of fun, especially if you're cutting curves on heavy plate. So you can have all these tools. It's not going to make you a better craftsman if you don't have the basics down. And so what I want you to understand from this video is like how to set up your torch and how to make a clean cut. Now, if you need guides, then this is a circle guide, so you can attach your torch through here and tighten it up. And of course, this is your standoff. Your standoff gets tightened, and then you can put a pin through here, and then it will. Oh, here's another wheel, but you can put a pin through here so you can cut. And if I put this way, you can cut circles with it. It's not perfect, but it makes a big difference versus trying to cut a circle by hand. But sometimes devices like this are in the way. One of the most common device I use is a guide. So if I wanted to cut like a dart off of here, then what I'll do is I'll clamp a guide on, and the guide needs to be, for me, it's particular because you've got a taper on that torch. And if the guide is too tall, then it's going to force you to. So say for instance, I used this as a guide. Problem is that I'm going to have to space my guide away from my line so that I can get a nice clean cut. But this, I can get real close to my line, and also the thickness of this bar, it won't distort with the heat of the cutting, and so this will give me a straight cut. And I'll demonstrate this also. So first I'll demonstrate this, and I'll pull away from it, and then I'll do a plunge cut. So again, careful placing your torch down, and always leave your tip cleaner out so that it's available And if I don't get that stinger, then it's just a second to bring it back up. If I cut a piece of W-shape, I-beam or H-beam or a large piece of plate, typically a little bit of carbon or a little bit of iron, this creates like these little balls, and it'll get stuck on the preheat or the oxygen orifice. So it's a good idea to keep those around. And I can tell right now if it's still clean if I've got a stinger that spits. So again, right to the point in time where your smoke disappears, then give yourself your oxygen. There's your feather, and there's your cone, and there's my stinger that spits. Okay, so now what I'm going to do is, on a long cut like this, what I'll do is I'll preheat the metal just a little bit. What the preheating does, it does several things. It will burn off any moisture. It will pop off rust and scale, and it'll bring it a little closer to kindling temperature. So when I make a cut, I have to think about ergonomics. So first of all, I want to make sure that the torch is balanced in my hand. I don't want to fight with that. Secondly, I want to make sure that the line is not fighting me. You can get, this is 3/16 line. For smaller work, you want a smaller line because this is a lot more flexible than 1/4 inch line. 1/4 inch line, you have to fight the line, and it's also like always, so it's so stiff that you're fighting the line, you're fighting the orientation of the torch. So be careful about getting too large of your twin line, because it really interferes with the flexibility of the torch itself. So typically when I hand cut a straight line, I don't cut it drawing it to me like this. When I do this by hand without a guide, when I go into cutting this, for instance, I won't use the guide, and I'll orientate my torch perpendicular to the line. And the reason why is because it's real easy to strike an arc, pretty clean arc. And I can adjust the radius of that arc by how long my arms extend. But there's no adjustment this way. And so I find that when I make long cuts without a guide, it's going to be better for me to cut with a torch perpendicular to the line than it is parallel. In this case, since the guide is guiding me, I'm going to pull it towards me because I can see what the preheat orifices are doing to the steel. I can't see it pushing away from me. But in this case, since I've got a guide, I don't have to worry about the ergonomics of it. So again, I'm going to bring the edge up to kindling temperature, enter the cut, and so this is cutting with the guide. Now you may want to tilt the torch slightly ahead of the cut so that if there's a rust in the material, it'll pop that rust off, but it won't stop the cut. Okay, so if your cut does stop, then as if I'm cutting off of the edge of the material, bring that edge, so this is my new edge, to kindling temperature. Start your cut in the groove, start your cut in the already cut groove, kindling temperature, start your cut here, and then keep cutting. And this has a lot to do with how rusty this steel is. And then I'll finish the cut. Now if your piece does not drop, you don't have good technique. So it should, whether you're keyholing it like this, or you're coming in from an edge, if your poor technique, marginal technique, is going to hang up. If you've got good technique, it'll drop. Best technique is you hardly have any of this dross. Okay, so that's cutting with a guide. Now what I want to do is I'm going to plunge cut in the middle. A guide can be curved too. So in this case, I bent this piece of steel in order to create that French curve in order to clean up the line of that surfboard. And so I could have a curved guide and just make sure that it's not interfering with the angle of the torch tip, because if you're like losing your line because you're fighting the taper on that torch tip, then the guide is not helping you out. All right, so now here's a cut that is tricky, but I have a technique, and that's what all this is about. It's not to replace your technique, it's to give you another approach. And if you don't have a technique, this is a good technique. If you have a technique that's not working well for you, then maybe adopt some of these practices. So now I'm going to plunge cut this, because I don't, say for instance I wanted a hole, but I don't want to compromise the integrity of the material. So again, I'm going to make sure that I've got a stinger that spits. And I do. Okay, so here's the technique. What I'm going to do is I'm going to sneak up on the steel. So I'm going to bring the steel to kindling temperature, and I'm going to slowly depress the lever, and I'm going to move the torch at the same time in like a spiral fashion. So in this situation, the disc is going to be the drop, and what I'm interested in is the hole and not the disc itself. So I'm at kindling temperature, okay, and you can verify. You don't have to pull it away every time. I'm just doing that for you, the camera. Now slowly depress the lever and then move the torch tip. Now, okay, so now I have a plunge cut, and the material still has its integrity. So that's my drop. And yeah, it's crazy to pick up hot stuff like this, but that's a clean cut. All right, so I went through the different cuts. Now what I'm going to do is I'm going to cut this star out, and so I'm going to cut the bare on my own time, because that'll be pretty tedious to watch this whole thing being cut. But we'll show you the bare after it's been cut, or maybe part of the process as well. So you know, after all of that, it doesn't hurt, you know, to just run your tip cleaner through, and you can kind of feel, I could feel it kind of dragging a little bit. So it doesn't take anything off as long as you're not, you know, sawing with it. And if you saw with it, then just get used to buying new tips, because you're not going to get the quality of the cut that you want. So I'll use the same technique as if I'm using this. Actually, I'm gonna plunge cut this, and I could. And here's my pet peeve, is that so before I get too far, Mel Board cut this sign, and he cut it by hand. And he cut this back in like 1982, before plasma, before water jet. So all of this is hand cut, and this has been outside. It's got a nice little patina, but I wanted you to see the kind of quality that people can get if they take precautions with their equipment, they follow the procedure, they work to specification, and he did fabulous work. I just have a lot of respect for that guy, and he really inspired me to improve my cutting skills. So I've been cutting this with a single aught, and to really get the best cut, probably a double aught. But like I said, you can push it one way or the other. If you know, maybe what I'll do is I'll go ahead and put a double aught on it, and make sure here's my double aught. Here's a brand new double aught. Maybe new to me, but it would new. But we'll see if we can get a stinger that fits on that. Because we should go ahead and, if I'm sitting there preaching, following procedures, then again, place your torch head down, and so that you're not in the air, nothing falls on the ground. So that's my single aught, and I'm going to place it with a double aught so it's smaller. my center orifice may have changed a little bit. Just really snug it gorilla, but not like full-on gorilla type. And then be careful with this so that it doesn't roll around. You should put that back in the case. And just for grins, I'm gonna see if it's the same size, which it's not. So it's a slightly smaller, and that's what that aught and double aught signifies. So it should be that one, but I'm going to say it's one of these two is going to be my that's tight. Don't force it. That's it right there. And I'm going to isolate that so I don't have to look for that every single time. Right now I have a torch cleaner, and again, frequently I don't ream the preheat orifices because they're really they do the job, but what is really important, and that's actually the same size tip cleaner for the double aught as it was for the single aught. I'm not a scientist who designs torch tips. I just use them, and so I don't memorize this, but that's handy. I might as well while I'm at it. When they swage these tips, it does bring up a concave surface on that torch tip, and that's handy because it can take a couple dings here and there. So this is dished. That preheat orifice is lower than the rim of that, and you can see in that where the oxidation was on that torch tip, it's worn off on the very edge because it's dished a little bit. And that's another reason why I've kind of waited until the last minute to reface that with a file before I, unless it really needs it, like I showed you in the drawing. If that center hole is not nice and crisp and it doesn't give me a stinger that spits, then I'll go over it with that really tame, mild file until I can see some copper color around those orifices, and then I'll ream those to get any gradu out of there with the oxygen lever depressed. Okay, so now I'm gonna plunge cut the star, and if all goes well, it's gonna fall. And when it falls, I don't want it to fall on my twin line. Again, make sure that you've got a stinger that spits. And I'm gonna go right in the middle. So that would be low, where it's just barely smoking. Right in the middle is where it's not smoking. High is where it's kind of urgent. You can, and then when it goes like that, you've got to reattach it. You got to back it back off. So I'm gonna go right in the middle, and then make sure this is on, and then I'm going to verify. I can always tell if I've got a stinger that spits if I've got a nice long feather. Okay. And you won't get that crackle if you've got too much pressure on your oxygen. It's not willy-nilly. I see people, it's like, yeah, set it at 40 and 20. It's just, no. Set it at the specific pressure that your torch tip requires. And then you'll get that. When you get that, you know you're going to get a clean cut. Okay, so everything's clear out of here. I'm going to do a plunge cut. You know, oh, the other side of it. Yeah, I'm sorry about that. It just bugs me when. So I had this instructor. He was awesome. His name is Leroy Humphrey, and he started the welding department at Austin Community College back in like 1973. And he was the man's man. He knew everything about anything when it come to like welding and blowing stuff up. Anyway, he brought in a large engine-driven generator and was repairing it. And one of my students picked up the cowl cover, the entire cover, and she cut a little flower out of it. And she didn't realize that that was for a customer's engine-driven welder generator. It was a Hobart or it was Lincoln or something like that. And then Leroy comes up to me with this shroud. It's probably cost like $500 to replace, I don't know. And he said, "Can you tell me who did this?" And I knew exactly who did it because it was my student. She made a chair and she put a little flower on the back of the chair. I thought it was really cute, but it was really not cute. So my point is, if you're going to take Leroy's shroud and you're going to cut a flower out of it, cut it out of the edge. Don't like right in the middle, so at least that you've got some like repair work. Now, I just laid this thing out, and I guess I'll do that some other time, but I would cut it out here, or I would cut it out here, so that I have all this material that I could use in another situation, but yeah, I just remembered that I have to lay that thing out again. So this is all going to come off anyway, so it's fine. But use your material wisely. It's very expensive nowadays. I think steel is about $1 a pound. I don't know the last time I bought it. And all this material is, I'll use this for something. So here we go. Oh yeah, it's music to my ears. Okay, so I'm gonna plunge this. So by the time I get to, where's my striker? Oh. So by the time I get to my star, I should have a clean cut. But this part is going to be dropped. I'll cut the outside of the star, so you have to decide, are we going to cut the line outside or inside? So here we go. Okay, again, remember when it stops like that, it hit a little piece of rust, then go to as if this is the edge, then start your oxygen in the slot. Okay, now what I'm going to do is I'm going to reorient myself, because I'm noticing pulling, I don't feel as like feng shui when I'm pulling as if I'm going cross perpendicular to my body. Okay, so this is starting to become a situation. Yeah, it's that rust on the surface. Pretty deep. Now it didn't drop because it got hung up there, and that's a good indication that I need to like slow down a little bit because of the thickness of the rust on this. Notice too, where you make those cuts, like here, at the tip of the star, it fused back together, and that's because when you got so much heat that's in that steel, you don't move fast enough, and that metal is going to melt back together. So pay attention to that. Let me get a hammer to tap that. So it's not bad, but really where you can see on these points is where it fused back onto itself, because there's so much heat, and I got a little stop on that cut because of the rust, but otherwise it's acceptable. And I'm going to quench this, and what I want to show you real quickly is how to get that dross off. I guess I can do it hot. So you can take a file, or you can take a chisel, and you can knock it off. Get underneath the dross. So if you get underneath that dross, then it'll peel right off. so you don't have to grind or sand in order to get the dross off of your cut. Okay, so I'm going to proceed, and that kind of gave me a warning about the layer of the rust. You can see how much rust is on this plate. I did a light wire brush. I'll probably do a little bit heavier wire brush because that is going to interfere with your cut. So, so hopefully in this demo, what I did is I showed you a technique of cutting in from the edge, of plunging, using guides, adjusting your torch, adjusting your pressure on your regulators, looking for that stinger, that spits, cleaning your torch tips. I always do a little summary, and my hope is that my technique will help you improve your cutting technique. Now, one last thing to shut down your torch: turn your pressures off. Turn your pressures off here, so you still got pressure in your tank and you've got pressure on the line. Turn your pressure off here. You can see I did not creep on either one of these regulators. Now, before removing any pressure from your T bolts, bleed your line. And so point this away from, open spark, because that's acetylene. And there's my oxygen. Oxygen is just as dangerous as acetylene. So now my regulators read zero. Now turn these back off. Now release the pressure on your diaphragms. Not so much that the bar falls out, just enough that it's not pressing on your regulator. And your regulators will last for decades if you do this. I wouldn't shut it down every time. If I'm going to use it more than once in one day, I'll leave the torch up. But at the end of the day, always shut your torch down. Not to mention the fact that if you leave this on, it's going to leak a little bit, just a little bit. So maybe you don't come back in your shop for a week, and then you realize it's like half of your oxygen or your acetylene is gone. So always shut your torch down. At the end of the day, kind of like just a procedure that you use before you turn your stereo off. And I'll drape this. I guess I've been told that it's a bad idea, but it seems like it's not hurting anything. So that's how I shut it down. Okay, thank you so much for your attention. More videos to come. Yeah, I torch cut that.